check, 1 2 1 2, check 1 2 1 2. All right, so in today's video we're just gonna go through some Leetcode here today. So without further ado, hope you guys stay well. So what I'm probably gonna work on here is I'm gonna work on the Leetcode 150. We'll start there, and then probably sometime in the future we're gonna work on the more novel problems, shall we say. So here we go. And I'm just gonna quickly check to see that everything's all working here with my stream. Do do do. Check 1 2. Check 1 2 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 1 2 Check 1 2 1 2. Check 1 2 1 2. Check. All right, cool. 1 2. I think the audio's up right now. 1 2 1 2. Let me adjust my settings here. Check 1 2 1 2 Check 1 2 1 2. Check 1 2 1 2. All right, so all right, cool. 1 2. Without further ado, we're gonna get into the first problem here. I think what we're gonna work on here today is we're gonna finish up 2 pointers. So we'll go to Leetcode here and we'll solve 3 sum. So I'm going to clear this. So given an array, integer array nums, return the triplets nums I, nums j, nums k, such that I is not equal to j, I is not equal to k, and j is not equal to k, and that numbers of I plus numbers of j plus numbers of k is equal to 2. Notice that the solution set must not contain duplicate triplets. So as the Leetcode 150 states, we probably do need to use two pointers, but because of that, we do need to iterate through the array once. So that's going to result in us having a minimum of an O of n squared time complexity. Time complexity equals to O of n squared. Space complexity is going to be O of n because we do need to store the array here. So how do we do this? So have to handle duplicates. So essentially what we're going to do is we're going to iterate through the array. First thing we want to do is we want to check if the previous value is a duplicate. If so, don't process it. All right, we're going to define left and right pointers. Left being at I plus 1, assuming that the iteration is starting with I. Right being at the end of the array. So we're going to have our 2 pointers. So while left is less than right, we're going to determine what our current sum is at the moment, and we'll have 3 checks. If the current sum is less than 0, We do need to sort this, by the way. We're going to increment I or left by 1 if the current sum is greater than 0, since we want to find that nums of I plus nums of j plus nums of k is equal to 0. We're going to decrement right by 1, since right is at the end of our array there, right? So otherwise, we know that our current sum is the target we are looking for. So what do we need to do in that case? Well, check for duplicates to make sure that we are not appending values that are duplicates into our array, right? So after we do that, we're going to add the values to our answer array, then increment the left pointer by 1. So now that we have kind of an outline of exactly what we want to do, we want to get to coding now. So first step, nums.sort, answer is equal to empty array here. So for I in range, length of nums, if I is greater than 0 and nums of I minus 1 is equal to nums of I, we're going to continue. So basically you're going to skip over the duplicates here. Now we're going to define our left pointer to be I plus 1, right pointer to be length of nums minus 1, while left is less than right. We're going to define current sum to be nums of I plus nums of left plus nums of right. So if current sum is less than 0, increment our left pointer. Current sum is greater than 0, right, is going to be decremented by 1, else. So now we have to process the duplicates here. So in order to do that, what we need to do is while left is less than or equal to right, and nums of left is equal to nums of left plus 1, and if so, we're going to increment left by 1. Answer dot append nums of I, nums of left, and nums of right. And lastly, we're going to increment left by 1. And if all of that is valid, then we're going to return our answer variable, right? So let's see what she does. It shouldn't be left is less than right, I think. There you go, yeah. Just a little bug over there. And let's see what she does. And there you go. So that's 3-sum completed. We're good on 2 pointers now. So let us do longest substring without repeating characters. let's do that. All right, so let's see. Given a string S, find the length of the longest substring without repeating characters. All right, so we have ABC, ABC, BB, right? So this is going to be your classic sliding window problem. So what we need to figure out is we need to figure out what the conditions are. So if we have the case where we have, so we're going to use a hash map. So this is going to be a sliding window problem. And then let's see here. We're going to condition to slide the window. So in this case, if we have ABC, right, we have a left and a right pointer, right? The right pointer is incrementing, then we're adding values to the hash map. So it's going to be something like A, and then 1, B, and then 1, and then C, and then 1. And let's just say that this gets over here, and look at that. Now we have A is equal to 2, right? So now we're going to slide the window over, right? So this left is going to go to B, and we're going to store an answer variable that is now sitting at 3 because it's incrementing 1 at a time. So it goes 1, 2, and then 3, right? So that's going to be kind of how the algorithm works, right? So what do we need to do here? So now that I've explained how that kind of works, we're going to need to define a left variable. Starts at 0. And then we're going to use right as the iteration. So define a hash map, taking in a string / character value and an integer. And then we're going to iterate through each write in the string, add the values to the hash map if it exists. So our window condition if the value at the key of the hash map exceeds 1, we're going to shrink the window accordingly. So outside of the window condition, maintain your answer variable tracking the length of the window against the current max. So that's essentially how I'm planning to do this, and then we're going to obviously return the answer. So time complexity is going to be O of n, space is going to be O of n as well. So let's do it. Left is equal to 0, answer is equal to 0, hash map is a collections default dict that is of type integer. for right in range length of s if, so I think because it's a collections.default dict, we can basically do this accordingly. Then I'm gonna copy paste this while it's greater than 1, hash mat s of left minus 1 if is equal to 0, delete the hash map value at that particular point, increment left by 1, answer is equal to max of answer, right minus left plus 1, return answer. So I hope that worked. So let's give it a shot. There you go. So let's submit. And boom, it is complete. So that's the first question of the longest substring. So we're gonna go and we're gonna work on longest repeating character. Clear this. So you are given a string and an integer k. You can choose any character of the string and change it to any uppercase English characters. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. So for this particular problem, I think what I need to do is it's going to be the same sliding window terminology as it did before. The only difference here is we have to maintain the longest repeating character replacement, aka the value there. So I'm going to show you real quick here. So sliding window again. So what's the difference? Need to maintain the sliding window with the longest character replacement. So in order to maintain the I'll show you the pseudocode so that you guys know exactly what I'm talking about here. So we're gonna go, so define left answer starting at 0. And then obviously we'll need a hash map as well. Default dict of integers for each byte in the string s. We're going to add to the hash map window condition if the and then this is going to be the key difference here, and then longest character starting at 0, add to the hash map if the window minus the longest character is less greater than or equal to k, I believe. Shrink the window, take the longest character as the max of the current hash map value at right and longest character, So the window condition, if the window minus the longest character is greater than or equal to shrink the window, good. Take the max of the current window, and we're gonna return the answer. So I'm a little bit iffy on this one. It's been a while since I've done it, but hey, this is what we're here for. We're here to practice. We're here to practice the fundamentals. So that's exactly what we're doing here. So left equals answer equals longest character is equal to 0. All right, so hash map is equal to collections.default dict, and it's an integer as well. Makes our life a lot easier. For right in range length of s, hash map s of right plus minus 1, and then we're gonna try to find the longest character here. Max hash map s of right and longest character while right minus left plus 1 minus longest character is greater than or equal to k. We're going to shrink it, so hash map of s of left minus 1 if hash map s of left is equal to 0. Delete hash map s of left plus minus 1, answer is equal to max of answer right minus left plus 1, return answer. Let's see what she does. Oh, let's see. Yeah, so it's not greater than or equal to, it's just greater than, because you have to shrink the window there. Let's see what she does. All right, there we go. So that's all done. Just got to remember that it's not greater than or equal to. It's just greater than, because that's a condition that we need to shrink the window by. All right, so next problem, I'm going to do minimum window substring. All right, so minimum window substring. So given
at Anytime Fitness, your time is our time.
And m likes m of n respectively, return the minimum window substring of s such that every character in T, including duplicates, is included in the window. If there is no such substring, return the empty string. So this is a edge case here, so I want to keep that in mind. Substring, return empty string, can include duplicates. All right, so let's see here. I think what we need to do is we need to figure out how they got bank. So let's see here. We have string ABC, and the minimum window that contains bank is going to be B, A, and is not included, then C, right? So I think what we need to do is we need to maintain a matched variable as well as our typical values such as hash map, but I want to make a significant distinction when it comes to the hash map. Hash map is going to be a bit different due to the fact that we want all the characters in T. So what we want to do is we want to pre-process a hash map originally, and instead of decrementing the hash map, we are going to increment it. All right, so that's kind of how we want to do it, right? And then our edge case is, since we want to return the string, then I think it makes sense for us to want to track the window start and the window length. So that presents us a question: do we have our window length at 0, or do we have it as an infinite value? I think for our situation, the start at 0 or infinite may be better to start at infinite in order for us to handle the edge case, right? So what we need to do here is we're going to talk through the pseudocode now. Define left answer, or not answer, but window start. We're going to have our matched starting at 0. Have window length starting at infinite. Have a hash map being a collections.default dict of type integer. Then we're going to iterate through each character in T, add to hash map. All right, so we're going to iterate through each write in S if the character is in the hash map, decrement it by 1 if the character is in the hash map and greater than or equal to 1 we found a match, so we increment matched by 1. So what's our window condition? If the length of t is equal to matched, then shrink window. So we want to first calculate the window start and the window length. So how do we do that? So if the window length is greater than the window being right minus left plus 1, set the window length to right minus left plus 1, set the window start to left. Then we're going to increment our pointers by 1. Increment our left pointers by 1. And then we're going to have some logic in between here. So if it's in the hash map, we check if it's equal to 0. Then we decrement matched by 1. And then we do our usual hash map decrement logic. So at the end of the window here, then we're gonna have our length of our string here. So that would mean that we return the string from window start to window start plus length if the window start or the window length is not infinite, else return an empty string. All right, so let's give her a shot. See what she does. So left is equal to answer, or we don't need an answer actually. Window start equals to matched equals 0. Window length is equal to float infinity. And then hash map is equal to collections dot default dict integer. All right, I think that's what we need here. For char in t, hash map char plus minus 1. So that is pre-processing our hash map there. So now we're going to do our sliding window logic. So for right in range, length of s. So if hash map or if s of right in hash map s of right is less than or equal to 1, if hash map at s of right is greater than or equal to 0, we're going to increment matched by 1, while matched is equal to length of t. Since, you know, we added all the hash map, we want to keep that dynamic. If window length is greater than right minus left plus 1, copy paste this, too lazy right now. Window start is equal to left. Now we're gonna do our shrinking logic here. So we're gonna do if hash map s of left, or no, we're gonna do s of left in hash map if hash map s of left is equal to 0, matched -1, hash map s of left -1, and then we are going to increment left by 1. So if we print our s window start, print window length, we just want to make sure that we have all of our ducks in order. Okay, so there is a little bug here, so let's figure out what's going on. Because as you can see here, if we look at the output, we can see that window start should not be at the beginning. So it's not finding the minimum here. So let me print hash map to see where I'm going wrong here. Let's see. Da, 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 da. So 1, 2, 3, 4, 5, 6. Plus window length. A B E Alright, so Californication says good job. I wish I could do it as well. Leetcode is a pain. I mean, at the end of the day, it just takes practice. Like, I've taken my fair share of technical interviews. I've done way too much Leetcode problems, so yeah, I mean, it's just practice, that's all. And I will say that I still have a lot of work to do in terms of preparation. Like, I still struggle with like new problems, but it's important to go for me over the fundamentals before I get there. So I'm just going through Leetcode 150 for now, and then making sure I understand that before I get to solving new problems. So that's kind of the plan here. And even though I have a interview in a little bit with Uber right now, it's still important for me to go over the fundamentals before I do that. So yeah, span right pointer until all the characters of T are covered. No, it should be equals. All right, let's see. What is going on here? Ah, I see. So I can't use the collections.default date. hash map char is equal to 0. No. Alright, let's see here. I fucking hate these solutions. Hmm. Okay. Oh, I'm stupid. You have to increment this, not decrement this. Alright, I'll get back to this another grind stream, but obviously couldn't solve that problem, so we're going to resume that another time. I do have an interview with Uber coming up soon, so I'm going to end the stream in a little bit, so just to let you guys know. Alright, so let's do some stack problems now. Valid parentheses. So this is a very classic problem here. So, given a string S containing just the characters open bracket, close bracket, open curly, close curly, and open square, close square, determine if the input string is valid. So an input string is valid if open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. So what we want to do here is we want to use a stack solution. So a stack solution is going to result in a time complexity of O of n and a space complexity of O of n. So how do we do this? Well, we want to store a hash map that stores the associated open and close brackets together. We consider that the open brackets, the close be the key, the open be the value. That way our stack, define stack that will store associated open brackets. So iterates through each character in the string. If the character is an open bracket, aka in our hash map.values, add to the stack. If the stack is non-empty and the character is its associated close bracket, pop from the stack. Otherwise, we have found a non-matching close bracket, so we return false. Then return if the stack is empty. So let's do this. So stack is empty to start out. Hash map is going to be a dictionary. We're going to start with the closed and the open. What else do we need? Curly and curly and what's the last one we're missing right now? Square. So for char in S, if char in hashmap.values, stack.append char elif char stack and stack -1 is equal to or okay, what? Oh my god. Hash map. Oh yeah. At char is equal to stack -1 stack dot pop else return false return stack is equal to empty. Cool. All right, we're going to solve one more problem and then we're going to call it a day for now. So that's valid parentheses solved. So now let's solve min stack. All right, so design a stack that supports push, pop, top, and receiving the minimum element in constant time. So implement the min stack. Min stack initializes the stack object. Push pushes the element onto the stack. Pop removes the element on top of the stack. Top gets a top element of the stack. And get min returns the minimum element in the stack. You must implement a solution with O(1) time complexity for each function, right? So the naive approach here is to just find the min value by taking the min value in the stack, but that's an O of n operation. So in order to solve this, what we need to do is we need to have a tuple on our stack storing the min value at the top, right? So we have a self.stack is equal to that stores the value and the min value as its tuple. So if not self.stack, stack self.stack.append val else min val is equal to min of stack -1 1 val stack pen val min val self.stack.pop. Pretty easy there. Return self.stack -1 0. Get min is return self.stack -1 1. All right, cool. That worked. And boom, there we go. So I'm gonna end the stream here. I got an interview to prepare for. I gotta eat. So hope you guys enjoyed the stream, and I'll see you tomorrow.